All right, so let's move on to another question in exercise 5C. Okay, so now you know how to calculate the line of best fit, right? So let's go for another question to practice with that. So they say here the relationship between the number of coats of paint applied to a board and the resulting weather resistance was tested in a laboratory. The data collected are shown in the table. Can you see? So they are testing the coats of paint that's applied and the protection, the number of years of protection. So they have found out if there's one coat of paint, the protection is there for 1.4 years. If there are two coats of paint, the protection is there for 2.9 years. For three coats of paint, the protection is there for 4.1 years. So you can see the relationship. Basically, the more coats, the higher the number of years of protection. Right, guys? Can you see? Okay, so they're saying find an equation of the regression line of y on x as a model for these results. Give your answer in the form y equal a plus bx. They're asking you to get the line of best fit. So guys, you know how to get the line of best fit y equal a plus bx. So what was the equation? B is equal to sxy over sxx, right? And a is equal to y bar minus bx bar. Are you with me? So you have to give these, let's give the summary statistics, let's give these data in the cal. I showed you how to give the data in the cal. And let's get the summary statistics. Right, guys? So let's get them. All right, so let's give everything in the cal. So you have your calculator here. So what you do is let's just press mode and give change it to stat mode. Okay, now different calculators will have different paths to go into this. So you'll have to, find them at the linear cal, but it's definitely there in every calculator. Okay, so you should be able to get summary statistics. Once you come to this particular string in your cal, I have to go for the second option, a plus bx in this cal. Okay, and then the xy column. Okay, so you should be able to get this look in almost every cal. Okay, so xy look. So coats of paint. So the value 1, 2, 3, 4, and 5. All right, guys, and the y value, the protection 1.4, 2.9, 4.1, 5.8, 7.2. Right, guys? So make sure when you are typing this, this is the most important thing. Make sure you double check your data set, okay? Because if your data set is, if it is wrong, then all your summary statistics will be wrong. Okay. So make sure you double check it 1.4, 2.9, 4.1, 5.8, 7.2. Double check your data set. Okay, guys. That's extremely important. 1, 2, 3, 4, 5. Okay. Right. So we are ready with our data set. So once you have given your data set, you can, as long as you don't change the mode, now you can see I'm currently in stat mode. As long as I don't change the mode in my cal, I will have my data set. Okay, so I explained this to you all previously. So you go to shift, and in this calculator, we go to the stat functions by giving this over here, because you can see the stat distribution on top of this button number 1, right? So in this cal, we go in this manner. So try to find the method in your cal as well. And then guys, if you go over here, you get this. This is what you need to go to. Okay, so if you press number 2, you'll go for the data. Okay, so number 2, and you can see this is the data that we gave. So it's stored in the calculator. Okay, so I don't need, now I need to get the summary statistics. So I'll just go to the shift, go to shift and distribution again, and now go for number 3, sum. And here you have all the summary statistics that you need, right, guys? So take the summary statistics. You need the sigma x square, you need sigma x, sigma xy, and sigma y, right, guys? So for sxy and sxx, all right. So let's get those values. Sigma x square is 55. Sigma x square is 55. Sigma x. So these are the summary statistics we need, right, guys? Do you remember? So I told you how to get them manually also, but yeah, we'll get them from the calc quickly. Just get these 4 answers. And then again you press fifth one and go to sum. And then let's get sigma x, that's number 2. Sigma x is 15. And then let's get sigma y. Sigma y number 4, that's gonna be 21.4. Sigma xy. Sigma xy is number 5. Can you guys see? Sigma xy is number 5. 78.7. Can you guys see what I just did? So now after you come to this stage, let's input the values. So it's xy. Sigma xy minus sigma x sigma y over n. Right, guys? All right, guys. So Sxy is gonna be sigma xy. That's going to be 78.7 minus sigma x sigma y, guys. Sigma x is 15. Sigma y is 21.4 divided by n. So what's n? N is the number of data points, guys. So we have 1, 2, 3, 4, 5 data points. Can you see? There are 5 data points. X, Y coordinates, we have 5 of them. All right, guys. So make sure you show this working. This is what you get marks for. Right. Okay. So let's type this in the cal. Let's get the answer. All right, guys. So this is 14.5. You can give this in your cal, right? Let's get the next statistic Sxx. So this is sigma x square minus sigma x whole thing square over n, right, guys? So sigma x square, we found this how statistics from the cal. Can you see? It's 55 minus sigma x whole thing square, guys. Sigma x is the addition of x values. That's 15. So 15 whole thing square divided by n. N is again we have 1, 2, 3, 4, 5 points. So we have 5 points. So let's type this in the cal. Let's get the Sxx values, guys. All right, guys. So Sxx is 10, right? Okay, so then let's get the values. B is equal to Sxy over Sxx. So that's going to be 14.5 divided by 10. So that's 1.45. That's the gradient of our regression line, right, guys? And let's get the A value. A is y bar minus bx bar. So A y bar minus bx bar. You know, y bar means the average of the y values, right? So sigma y over n. You guys know that, right? So y bar means you add all the y values and divide by the number of y values. X bar is you add sigma x over n. Right, guys? This is something you learn in chapter 2, isn't it? X bar is sigma x over n. We discussed this in chapter 2. It's a very simple equation. This is y bar sigma y over n minus b times x by sigma x over n. All right, guys. So sigma y is 21.4 over n is, we have 5 points, right, guys? We have 5 points. And for B, we have an exact figure 1.45. Okay, so in an event, if this was not an exact figure, I would go for the fractional figure, okay, or the full value. So over here, anyway, 1.45 is a full figure, so we'll use that. Into sigma x over n. That's what sigma x? Sigma x is 15. Okay, I can see the sigma x value is 15 over n is 5. So once again, let's type this in the cal. Let's get the answer.
Yeah, we finished it.
Minus 0.07. All right. All right, guys. So let's try the equation of the regression line, the line of best fit. Y equal a plus bx. So y equal, guys, a is 10, right? No, sorry. A is 0 minus 0.07 plus b is 1.45 times x. All right, guys. Okay, so we are done with this part. Okay, so let's move on to the next part. Okay, so what do they say here? Okay, so we are done with part A. Part B, interpret the value of B in your model. So how do you interpret the value of B in the model? Okay, so I have given you very clearly a note for the, the the interpretation of the intercept and the interpretation of the gradient, right there? So turn to that note. Alright, guys. So this is the note I gave you all, right? So in the beginning of this chapter, interpretation of gradient. So this was part of the notes. I just took it to show you guys. So you can see the main interpretation I go is the second one. When x changes by 1 unit, y increases or decreases by the gradient. Okay. So make sure you also use the correct units. Now you can't write x, y. You have to use the correct notations according to the variables that they have given. Okay, so explain, interpret the value of B. So what do you say? So for the x is the coats of paint, right? So when x increases by 1 unit means what? So when you add an extra coat of paint, right? So for every extra coat of paint, try to make it try to make it try to make sense of the statement. Okay, for every extra coat of paint, for every extra coat of paint, what happens, guys? For every extra coat of paint, the what happens for every extra coat of paint? The protection, because here the y means the protection in years. Okay, so the protection in this case, we have a positive gradient, right, guys? We got a positive gradient. Am I correct to say that? Yeah, our b value was positive. Can you see? Our b value is positive. So the protection increases because it's a positive b value. Protection increases by how much? By the b value. What's the b value? Our b value is 1.45. 1.45 what, guys? What's the unit? The unit of y, y is in years. So for every extra coat of paint, the protection is increased by 1.45 years. Every extra coat of paint increases protection by 1.45 here. That would be the grammatically correct statement, right? Okay, guys, so this is how you interpret your gradient. Are you with me? All right, and then let's move on to part C. Explain why this model would not be suitable for predicting the number of coats of paint that had been applied to a board that had remained weather resistant for 7 years. Okay, so why can't we use this model for 7 years? Now, I mean, when you have a regression equation, you can substitute the x value and get the y value, right? You can input the x value and get the output y. Okay, so x is the coats of paint and y is the protection in the air. But they are saying here, explain why this model, what we got here, the equation that we got, this equation, okay, why this model is not suitable for predicting the number of coats of paint that had been applied to a board that had remained weather resistant for 7 years. So, why is it not suitable? Okay, guys, in part C, I think there's a small error here, right, guys? Because the thing is, you need to understand that when you are using regression lines, okay, when you use y equal a plus bx type of regression lines, okay, remember y is the prediction. Okay, you predict whom? You predict the y value, your response variable or your dependent variable. X is the independent. Right, guys? X is the independent variable and you input X values to get outputs for Y. Are you with me? So Y is the prediction that you make. So now, and if you remember, we did something called interpolation and extrapolation. So then the rule was if you want to predict Y values, your X input has to be what? Your X input has to always be in this range. If your X input is not within the given range, then the answers are not reliable. Do you recall? So here your X values are between 1 to, I mean, you have X values from 1 to 5. So anything inside 1 to 5, if you input X, that's fine. And the answer you get for Y will be reliable. right guys? But if you put anything outside of x for y, I mean outside of this range, say you put some value 10, so you can see it's definitely outside the range. Then such answers for y are not reliable. Do you recall? So we did this in the previous part, right guys? But now the thing is, I think in this question here, so they are saying, I think there is a small typo here, right? So this should be because I mean, they are saying explain why this model would not be suitable for predicting the number of coats of paint. Guys, we are not predicting the number of coats of paint, right? Because coats of paint is X. Okay, so we are predicting the number of years of protection. That's our prediction. Okay, so we are predicting the number of years of protection. Okay, so I think this needs to change here slightly. Okay, explain why this model would not be suitable for predicting the years of protection. Okay, years of protection for a boat that had remained for a boat that has 7 coats of paint. So these two variables need to change. Okay, guys, because we are predicting the protection in years. Okay, not the coats of paint. We don't predict the coats of. We don't predict X. We predict Y. Okay, so that's a small typo. So you have to change those variables. Okay, the X Y has to interchange here. So basically, what they're trying to say here is if you have explain why this model would not be suitable for predicting the protection for a boat that has 7 coats of paint. Okay. So for a boat that has 7 coats of paint, why is it not going to be suitable? Because guys, you can see you only have until 5 coats of paint. Do you have for 7 coats of paint? Do you have until 7 coats of paint? You don't have enough data. Are you guys with me? Okay, so you can say 7 lies outside the range. 7 lies outside the range of data. 7 lies outside the range of data. Therefore, so this is extrapolation. Extrapolation answer is answer not reliable. All right, guys. All right, guys. Moving on to part B. Use your answer to part A. Okay, so use your answer to part A. In part A, we got the regression line, right? Use your answer to part A to predict the number of years of protection when 7 coats of paint are applied. Okay, so let's do that. So we are actually going to use x as 7 now. Part D, so y equals minus 0.07 plus 1.45x. So 7 coats of paint are applied. We know the answer is not reliable. So let's, anyway, they're asking us to calculate this not reliable answer. We'll calculate. Okay, we know 7 is outside the range. We know the answer is not reliable. But in part D, they ask us to calculate. So let's input x as 7 and let's get the answer. Okay, so what's the answer, guys? All right, guys, so it's 10.1 years. Okay, so this is our answer. Okay, now moving on to the next part, they say in order to improve the reliability of its results, okay, to improve the reliability, the laboratory made 2 further observations. So coats of paint is 6 and 8 and protection 8.2, 9.9. Guys, are you with me? So the laboratory has made 2 further observations. Using all 7 data points, produce a refined model. Guys, how do you produce a refined model? A refined model means what? You have to take these values and also include these 2 guys. Are you with me? You include these 2 values to this and you produce a refined model by how? By calculating the A and B values all over again. That means you get your summary statistics again. Are you with me, guys? So now I hope you did not change the mode in your cal, because if you didn't change the mode, you will have your data point. Okay, so all you have to do is, guys, you have to add 2 extra values to your data set. So if you didn't change the mode, all you have to go is to go to shift 1 and you go to what? Go to the data set now. Okay, so go to the data set and you can see you have your data here 1, 2, 3, 4, 5, and then let's give the next value. So coats of paint is 6. Are you with me, guys? And coats of paint 8. So 2 extra data points. Are you with me? 2 extra data points. Okay, guys, and then what we do is let's go for the y values. So when x is 6, y is 8.2. Are you with me? Make sure you give them in the Kelvin. Y x is 6, y is 8.2, and when x is 8, y is 9.9. So these are observed data. All right, guys, can you see? So you add 2 new data points to the ones that were already stored in your calculator. All right, guys. Okay, so now what we'll do is let's go for the summary statistics. So shift 1 and sorry, let's press the button again. Now let's go for the summary statistics. So number 3 is sum, and guys, you know what you should do? Get sigma x square, sigma x, sigma y, sigma xy. Get all 4 of these summary statistics and let's calculate A and B all over again. Okay, so let's do that quickly. All right, guys. So we get the answer. So I think I wrote down all the workings really fast. Okay, so just so that we can save our time. So Sxy, the new summary statistics are found. Okay, so we gave the inputs. You can get the outputs and get the Sxy, the Sxx, get the B value. Right, guys, get the A value, and you can get the gradient and the intercept and give it to normally we can give it to 3SF. Okay, but the thing is when you're substituting the B value to get the A value, you know, A depends on B. So in that case, give a higher significance. Don't give the 3SF answer for B over here. Give a higher, maybe give it around 6 or 7SF, or you can give the entire fraction. I gave the entire fraction. Okay, but the thing is, when you're writing your regression line, we write it with 3SF. Okay, guys? And you can specify your significance. So y equal A plus bx, y equal A 0.478 plus B is 1.25 times x. All right, guys. Okay, so that's the answer for, yeah. Okay, so I think we have a few more parts, right? Yeah, so that's the answer for part 1, produce a refined model. Okay, Roman number 2, using your new model to predict the number of years of protection when 7 coats of paint are applied. Can you see? So now they have corrected the question here. Okay, so that was what they wanted to ask here also. They are asking you to use this new model to predict the number of years. Okay, so that's exactly what they want here. To predict the number of years of protection when 7 coats of paint are applied. So what do you do now? You have your new model. Okay, so you apply what? You give 7 years here now. Now this is the refined model because you have included 2 more data points. Okay, and that with the 2 new data points, you are able to what? You are able to cover the 0.7 as well, right, guys? Do you see? Because it's exceeding 7. Okay, so shall we input the x as 7 and get the number of years of protection? Okay, so let's get the prediction. What's the prediction when x is 7? All right, guys. So then they're asking you now in part 3, give 2 reasons why your new prediction might be more accurate than your original prediction. So what was the original prediction? The original prediction was what we did in part C. The number of years of protection when 7 coats of paint were applied. We did one in part C and we did one in part E. Okay. So how does it change, guys? The thing is, when you were working in part C, you only had 5 data points and you only had until 5 coats of protection. So you predicted the years of protection for 7 coats when it was outside the data range. Right, guys? So basically, that's why we told that the answer that we got in part C is not reliable because we were doing extrapolation. But now, when you when you got the number of years of protection in part E, guys, in part E over here, you can see that you included 2 new data points. And now when you include these 2 new data points to the original data set, the value 7 is not extrapolation. It's inside the data set. Are you all with me? So therefore, you can see that it's now not, it's now inside the data range. Okay, so the original prediction was extrapolated. So that's one reason why it is, this one is, the answer we got in part E is more accurate. Okay. And then another reason they are asking you 2 reasons, guys. What's the other reason? Reason number 1 is the answer in part C was extrapolation and the answer in part E is interpolation inside the data range. That's one reason. The second reason you can say what? Guys, normally the thing is when you are taking this line of best fit, it's always better to what? To get the line with lesser points or to get the line with more points. The line is better. The more points you use, the better your line is. Okay, so that's one of the other reasons. So you can say the in model in part E, the second model has more data points. Therefore, it is better than the previous model. Okay, guys. So these are the reasons that you can give. Okay, so I'll repeat that again. Y'all can write it down, right? So you can see the original prediction was extrapolation, and the new prediction is interpolation. That's one reason. The other one is you can say in the second prediction, there are more points have been used to generate the line of best fit. So therefore, it is better. You can say something like that. All right, guys. So I hope this is clear with you all because this is a complete full question in your exam. So you need to be able to understand this theory and you need to be able to calculate the line of best fit and also give predictions and also say and also be able to say whether your answer is good or bad. Okay, you need to make predictions and say whether the prediction is reliable or not. All right, guys.